Hello and welcome to today's episode of Code and Coffee. My name is Brian Selby. I'm your host, and I will be demonstrating some residential modeling, um, tips, tricks. Today we're going to be looking at an E+A+A project. We've never done this before on a Code and Coffee. So if you're watching for the first time, thank you for tuning in. We do record this broadcast live. So if you want to join a live broadcast, subscribe to the Code and Coffee YouTube channel and or the EnergyCode YouTube channel. You get a notice. Also, subscribe to the EnergyCodeAce.com website, and you'll get notices when those Code and Coffee episodes will be broadcast. Today, our Code and Coffee is brought to you by our EnergyCodeAce.com team, which is funded through the auspices of the CPUC, through the statewide codes and standards team, under the umbrella of the compliance improvement portion of the statewide codes and standards team. So they have invested in your training and equipping you to understand and apply the energy standards, specifically with modeling projects using the state-approved compliance software. Today, we're going to be using EnergyPro. So here's our introduction to our project today. We're going to be using EnergyPro, and we've updated this recently. EnergyPro is now using version 7.2.4. A couple little things I want to show you today that are very specific to this new version. So if you use Hvac Res, these features are also available. Someday, if there's enough interest and you guys want a demo using Hvac Res, I'll be happy to do that. So just hit me up in the chat window if that's you, or leave a comment on the comment section below. So let me introduce our project. Today we've got a single family residence located in Climate Zone 12. I know I do a lot of Climate Zone 12. I live in Climate Zone 12, and I do a lot of work there. So if you have any suggestions for projects that are outside of this climate zone, feel free to email me. Send me those projects. I'd be happy to do an episode on those. So today we have an addition, and it's a fairly ambitious project. So I've never been nervous about a broadcast before, but today a little bit nervous because it's a lot to do in a small episode here. So we're going to be reviewing the plans. I'll show those to you in just a second. We're going to be doing our takeoffs. I have gone ahead and prepared a little bit of the model. I've modeled the existing house already. So we're going to be making some alterations to that existing house, but it was just too much to model all in one episode, the existing house and the additions. I say additions because it's an addition to a house and converting a garage to conditioned space. So there's a lot going on here. So let's dive into our project. I'm going to switch to my my screen here. I'm using Bluebeam, which is a PDF viewer and markup software. I find it helpful. If you use it, great. If you use Adobe or some other PDF software, great. Just use what is most proficient for you. I found this is very proficient for me. So we've got a project here. As you can see, it's a fairly large project. We've got a lot going on here. I've done a little bit of work ahead of time to model that existing house. But let's take a look at this existing house. We've got a 2,100 and, let's say, round numbers, 25 square foot existing house. You can see it's a 3-bedroom, 2-bath house. We've got an existing attached garage here. Let's look at the scope of work that we're going to be doing. So I've highlighted the existing house just so you can see this on the screen. So everything that's blue is existing. We're going to be adding a new utility room over here. You can see that this utility room is fairly small, 12 by 14, and a new garage. And then we're converting that existing garage over here to conditioned space. So putting in a bonus room, they're expanding that closet. So we've got a lot of work to do here, and I want to dive in and get started. here. So bear with me while I change screens on my other monitor. So if you're like to see what my desktop looks like, this is it. This is where I work. This is my it's not a studio, it's my desk. So this is me. And for those of you that have received a Code and Coffee mug, you know, hopefully you enjoy these. I enjoy mine, and we're going to be doing our regular, I wouldn't call it a competition, but you know, if you ask questions, if you're most frequently asking questions, we're likely to send you a complimentary EnergyCode Ace and Code and Coffee mug. So anyways, let's see, do we have any questions? Looks like everything's good on the question side, so let's dive in. I've already modeled the existing house. You'll be able to see my model here in EnergyPro. We've gone through and taken care of that already. So I just need to find my pencil. Let me go back to the. So this is my existing model. I've modeled it. Everything that's existing is labeled that way. So all my surface types are existing. All my windows are existing. The water heating and heating systems are all existing. So we're starting kind of ahead of the curve here. So I want to highlight what's unique to doing an E+A+A approach. So let's take a look at our plans here. I'm going to start in the utility room. That's going to be my zone 2. So zone 1 is my existing house. So let's start with the area. I just want to calibrate my model, make sure that it is indicating the right dimensions here. Let me just go to a linear dimension. So this is just a way to set the aspect ratio correctly. Okay. I'm going to start with a area. Start on my takeoff. By the way, this is a very simple slab on grade house, 8-foot plate, existing conventional gas furnace and air conditioner. As I'm doing this, I am going to show you kind of some ins and outs here. I'm going to subtract that water heater because that water heater is open to that garage, so it's not part of our conditioned floor area. Okay, we have 100 and let's say just round numbers, 166 square feet of laundry room. Being that this is a slab on grade, I'm going to do my slab edge dimension. So we have, let's say, 11.5 feet here minus this little slab edge for, so let's say 2.5 feet. So what is that? About 19, 20 feet approximately, slab edge. Let's go over and do our areas for our garage conversion. Let's figure this out real quick. So a couple of features I wanted to highlight that are new to our compliance software. Extended walls and walls that have existing siding. These are fairly new exceptions that can be used in the performance approach. And you may be aware of them already, and we're going to be able to utilize both of these. Well, actually, the one feature, we're going to be utilizing walls with existing siding on it. So it works essentially the same. So what that tells my standard design is that those walls are not subject to the more I would say restrictive requirements of the prescriptive approach or the high performance walls. So we get kind of a pass there. So almost done here. We've got our addition right about 600 square feet for the bonus room. let's just do a real quick perimeter dimension. Anybody have any questions? Any questions coming up? No, looks like we're good on the question department. Good. I'm just using the perimeter dimension tool, and I'm just following around the outside here. So when you use Bluebeam or other software, it may not be as choppy as this. I've got a lot of stuff running on my system right now. So we have 54.5 lineal feet of slab edge. All right, good. We've got our area takeoffs. We've got a good idea. I'm going to give you a shot of the elevations of this house. Truss roof. I've already modeled the overhangs that were added onto this existing house. Unfortunately, you can't take advantage of additional overhangs. You just either model them on the existing or not. Maybe in the future, it'd be nice to have that of adding an overhang as an alteration, but right now it doesn't work that way. So you can see here we've got, I believe, an 8-foot plate going on, truss roof, R38 in the ceiling, slab. Our existing walls are 2x6, so the existing R19 insulation in there. We're going to be adding a lot of features to this model. So, all right, let's start with our front of our utility room. I've got, let's say this is a 12-foot wall. It's 96 square feet. I've got 2 windows. Now, in this case, these windows are molded together. They're two 630s. I could say that that's a 5030 or enter 2 different windows. If you followed along my YouTube broadcast, that I like to do individual windows. That's just my style. If my client calls me up and says, I want to make a change later, it's easy for me to do that. Or if you prefer, you can just lump all the similar windows in the same orientation together in one big area. That's fine. In this case, I'm going to combine those 2 windows as a new 5030, so 15 square feet of window there. My left wall is a demising wall. I don't have a left exterior wall. I'm going to handle that as an interior wall later. So my back wall, we're going to subtract that 2.5 feet. Let's see, that's 9.5 feet times 8. That's 76 feet. I've got a door back here. I need to look at the elevations and see what that door is. It says there's tempered safety glass there, and that gives me a good idea that there's probably a half light or full light. So in this case, it is a half light. Now, just you have to remember the rules for this. If the door is more than 50% glazing, then the entire door is fenestration. If the door is less than 50% glazing, then only the glazing plus 2 inches around that. And I'm guessing here, you can be more precise on your end. But I've got 7.8 square feet. This is a 2668 door, so we definitely have less than 50% of that door is glazing. So what I'm going to do is I'm going to record the half light as 7.8 square feet, and I'm going to indicate the door is the remainder, so it's an opaque surface. So if I have 17.8 minus 7.8, that's 10 square feet of door. All right, okay, let's jump back to our floor plan here. So we've got an interior surface from the utility room to the garage. We're going to have an interior surface from the existing house to the utility room. So we'll handle those. Let me just collect that information. Now, we've got 2 different wall types here. You can see because of this little closet for the water heater, I've got a certain amount of that wall is 2x6 wall, and that's 11 feet. So that's interior adjacent to the new garage. I've got let's see 11 feet, so 88 square feet of 2x6 wall, and I have the remainder of that times, and we have 14 inner, 8 times, minus, so we have 24 square feet. It's the interior wall adjacent to the new garage. That's 2 by 4. Now, if you're, let me just do my little over-the-shoulder shot here. So, again, I am very simple here in my data collection. I write everything down on a quad pad. So, if you have a spreadsheet or you have a takeoff sheet, whatever works for you. But this is my style. It's been working for, gosh, I've been doing this since the 80s. So, I won't say how old I am. All right, let's go back to our project here. So we got our interior wall adjacent to the garage. I am going to write down my interior wall adjacent to, from the existing house adjacent to my proposed utility room addition. So you could look at this a few different ways. I mean, just the wall space. I'm going to say that we have, let's say 4.25, and what's this? 6 foot, and that's 8 foot high. Let's say 82 square feet of interior wall from the existing house adjacent to the laundry room, and that's a 2 by 6 wall, existing wall, and that was an existing exterior wall. So that's something that we're going to indicate on our plan. Okay, we've got everything. We've got our areas for the utility room. Let's move over to the garage here. I know we didn't do the area yet, but let's just do that real quick. Very simple in Bluebeam. Now, some people like to get AutoCAD files and do their takeoffs on that. That's awesome. I find my clients don't often give me that luxury. But if I do get it, it makes my life a lot easier. If you're not an AutoCAD person, you know, I learned a long time ago, so I like AutoCAD. But if you have a DXF file or a DWG file, you can download programs that will read DWG files and do that effectively for you. All right, it looks like Bippin has a question. It says, in half fenestration door has overhang. How do we model it in software? Just like you would a regular window, Bippin. You take the window width, window height. You're looking at the overhang projection, the height from the top of the window, so that window plus 2 inches from there to the bottom of the overhang, and the amount of extension left and right. So that would be identical the way you model window. Overhangs don't have an effect on the opaque surfaces, so the remaining door wouldn't have anything to do. So just the window portion of it. Now, if the entire door, if it was greater than 50%, the entire door, you would model it as the width is 2.8, height is 6.8. You would say it's so far from the top of the door to the bottom of the overhang, and left and right projections. So same thing. Does that help, Bippin? 811 square foot on a garage. Let's do a quick perimeter length around that garage. You know what? I'm just going to look at my plans. I've got 7 feet on this little alcove. My bottom dimension is 26 feet. My overall depth is, was that 33 feet? It's saving me a little bit of time. Another 26 foot, and what's this, 12 feet? So I've got 104 lineal feet of slab edge on my garage. Let's collect those opaque surface and fenestration areas. So I've got 26 foot overall width here times 8. That gives me 208 square feet. I've got 2 windows. I've got two 304 windows, so 12 square feet a piece on those windows. I've got no doors on the front side. As you know, I like to go from front going clockwise. So I'm going to go to my left side. Left garage is going to be, what did I say, that was 33 feet. That's 264 square feet. I've got two doors. I've got a 16 foot wide by 7.5 foot high door. It's 120 square feet. I also have a what's that? A 9076. So 9 times 7.5 is 67.5 on the door. My back wall is the same as my front wall. That is 208 square feet. I've got one window, 12 square feet. That's this window right here. And then I do have these returns. I have two right walls, so 7 feet and 12 feet. That is 19 feet times 8 foot is 152 square feet. No windows, no doors. So we're good to go. Let's move on, finish our takeoff, and complete this proposed bonus room. So all of these are going to be on the same floor height, same ceiling height, same floor to floor height. So I'm not going to worry about that right now. When we start modeling, I'll set all that. So Debbie says, will the interior surface between the addition and the existing belong to the addition or to the existing space? So Debbie, my philosophy is if I'm doing an E+A+A, interior walls from existing to proposed, those interior walls are going to live in the existing building. Now, there's no reason you couldn't put the interior wall from the proposed room to the existing house. But here's my principle behind that. If I'm doing a house to a garage, that wall, that interior wall, always has to live in the house. So I'm setting up good habits by saying I'm going to put that wall, if it's an existing wall, I'm going to put it in the existing house, and I'm going to show it adjacent to the new room. So that's my theory. I believe the software will work either way, but if you do an interior wall from a garage unconditioned space to a conditioned space, the software doesn't like it and says, no, you can't do that. So I just prefer to keep very consistent rules in the way I do my modeling. That way I avoid a lot of mistakes. So hopefully that answers your question, Debbie. Let's start with our front wall. That's what, 25 feet. I'm rounding a little bit here. It's a 25 feet 1/2 inch. So if you have a foot and inch calculator, can convert that. Great. I'm just going with round numbers. 200 square feet for the front wall. We don't have any left wall. We have a back wall, and that dimension, see if I can find it here, 5.5 feet. By the way, let's see. Sean says, if bonus is converted into separate unit, would you model propose as addition alone and the existing as EAA? In this case, it's all permitted together, Sean. If that bonus room is converted to ADU, then I'd run the ADU as a addition alone and use those new rules that we have for ADUs. But in this case, it's all one dwelling, so I'm doing all in one model. And I want to avoid confusing my plan checker so that he doesn't go, what did you do here? So, all right. I've got my back wall garage, let's see, bonus room at 44 square feet. We do have a window there. So 2640, that's 10 square feet. You do these enough, you look at windows, you don't look at dimensions, you look at areas. When you see a 2640, that's 10 square feet, you know. So let's see, my right wall dimension is 24 feet. So we know 24 times 8 is 192. Bonus room is 192 square feet. We've got a French door here. This is a full light French door. We could look at our elevations and see that over here. So the entire door is fenestration. We're just going to characterize it a little bit differently when we input that model. 6068 is 40 square feet. If you've taken my CA exam prep workshop, the res workshop, we talk about strategies for window dimensions if you're going to be doing overhangs. inputting that so you can avoid the multiplication factor on your fenestration sheet. So if you ever run across that, you know what I'm talking about. I may do a YouTube episode on that in the future. So 2 windows, 3050s, those are 15 square feet a piece. Good. I think we have our takeoff done. I didn't see any skylights. If you saw skylights here, no, I don't see anything. One thing I do want to note that, this is client communication here. The added laundry room is going to use the existing HVAC system, and they're going to extend ducts into that space. The proposed bonus room is not going to extend the existing HVAC system and only use that gas stove down here in the corner. So we haven't done this before. So again, new territory. So hopefully everybody's good with this and going on our modeling. We need our interior wall. And this, I'm just going to take a linear dimension because interior walls are not subject to orientation, right? Let's call this a perimeter dimension. So what we do here is we can just add up all this wall length, multiply it times our ceiling height. Sorry if I'm a little jumpy on the dimensions here. My system is a little slow today. And find my end wall. Let's call it 47.75 times 8, 382 square feet. Now this is from the existing house, 382 square feet interior wall, and this is adjacent to the bonus room. Again, back to Debbie's question about where does that interior wall live? The existing interior wall lives in the existing house, and we're going to indicate it adjacent to the bonus room. Good. Anyways, we're going to just practice good modeling behavior here. So, all right, everybody following along okay? I'm going to collapse this down a little bit just so you guys can see what's going on and not lose anything here. So I'm going to start with my laundry room addition. This is going to be a brand new zone. That zone is going to be called laundry room. And this is conditioned. It's new. It's not existing. So this is an addition. I'm going to come in here and set my dwelling units. There's no bedrooms in there. So that is 0. I'm going to turn my appliances off. Those of you using Hvac Res, you do this at the building level, and you can turn appliances. You can change attributes of appliances, but you can't take them off. Just keep in mind, appliances are a wash. Whatever you put in this proposed design is identical in the standard design. So just keep that in mind. I'm going to add a room here. My room is equal to the area of my laundry room, and that's 166 square feet. I know that I have a slab. I have 2 exterior walls, and I have a roof. In addition to that, I'm going to have an interior surface to a zone that I haven't defined yet, so I'm not going to input that information. So this is my laundry room, 166 square feet. My slab, we've already done our takeoff, right? It's 166 square feet. I'm going to leave this at default, 20% exposed. That's perfectly acceptable in this situation. I probably wouldn't run an exposed. I might run completely covered, but definitely wouldn't run it exposed. Set that exterior perimeter to 20 feet. Good, I'm done with my slab. Let's move on to my front wall. Again, start with the front. I'm doing my same process over and over again. My front wall was 96 square feet. Now, this wall is a new wall. It's not an extended wall. I don't get an exception for it. If you remember, we're talking about this wall right here. So let's see if we do that wall. I think the client wanted to keep all R19, so we're going to run this simulation with that new wall for the laundry room as R19 and see how that works. So our front orientation, I didn't write down, but I know this was 314 degrees. So my front wall is 314. I didn't have any left wall, but I did have some rear wall. I like to label these appropriately. Sometimes people have more elaborate naming for this, but if I know I'm in the laundry room zone, the front wall, it's adjacent to the, it's in the laundry room, so I don't need to go any further for me. So my rear wall is the same, a little bit less, 76 square feet there, R19, and 314 degrees. We're going to add 180 to that, subtract 360, gives me 134 degrees. Okay. My roof, it's an attic roof. The area is equal to my slab, 166 square feet. It's new. The client is going to be putting R38 in that attic. So let's take a look here. EnergyPro has an R38 roof with an attic. I always like to check the Res T24 Performance tab. JA4 tab doesn't work for performance. It's only for prescriptive approach. So if you have that model here, that looks good to me. Truss heel height's 3.5 inches. It's not unvented. We don't have any below roof deck insulation. My top cord's 2x4. My ceilings are 38. I'm good to go. Hit OK. I always set the front orientation of my roofs equal to the orientation of the house. Now, you might set it at 0. That's fine. One other input that you're going to need is the roof slope. And that roof slope is 6 and 12. So we're going to enter that. If you have a 0 and you put R8 or put ducts in the attic, it's going to say you don't have enough room up there. So make sure you put the roof slope relative to what's actually there. Let's go back and do our windows. We have a 5030 window, so 15 square feet on the front. We're going to use a placeholder here. The client didn't tell me what they wanted to use for windows, so we're going to use the prescriptive requirements here, 0.32 U factor, 0.25 SHGC, hit OK. We're going to enter another window for the back. Now, keep in mind, this window is a half-light window in that door, half-light door. So I'm going to call this half-light door. And I like to, 7.8 square feet. I like to use a default for that. And let me show you what I do. I'm going to take my double non-metal clear default value. I'm going to copy it. And I'm going to call that double non-metal clear door. Oh, it's already there. Let me just cancel that. Bring this back in. I'll show you how I do this. It's a manufactured door. Most likely they're going to have a door company build that door. If you had a door, you knew that they had an NFRC label, great. Use the NFRC rating on that. But I don't know that right now. So I'm going to model this as a default. I'm going to change my fenestration type to door. It will be a double pane, and that is an operable door. I'm going to say the frame type is non-metal. If it were a metal door, I would say metal or metal thermal break. But in this case, we're just going to call it a non-metal door, which is assuming wood or fiberglass, something like that. So that's how I would do that one. I think I'm done with my laundry room other than my interior surfaces. We could define that right now, but I just have nothing to connect it to. So if I'm in the house, what we say that was 88 square feet of 2x6 wall. This is a new wall. My floor elevation is equal to the floor elevation of the height. I need to go back and set that up. I'm not going to set who that is adjacent to yet because I haven't created that zone. So, but that does remind me, I do have to go back in and do my building story height. And right now it's all set. It's set based on my existing house. So the ceiling height's 8 feet. My slab elevation above grade is 0.7, which is, I do a 1 decimal point equivalent to 8 inches. We know that's 0.66667, blah, 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 all that. So we're going to avoid all those decimal places. Keep it easy. My floor to floor height, I set it at 9 feet. Anything above 8 foot is going to be floor to floor height for a single story building. So if you want to do 8.1, fine. If you want to do 9, if you want to do 20 feet, great. It has no effect on this model because it's a single story. I'm setting my window height at 6.7 or 6 foot 8 inches. So, okay, let's create our garage zone, separate zone. As long as the garage zone isn't your first zone in your tree, you can put it anywhere you want. So I'm going to label this garage. I like to copy and paste text whenever I can. I avoid typing. We're going to say that zone type is a residential garage. Now, I have a practice of changing the bedrooms to 0. The software knows that if it's a garage, there's no bedrooms in there, but it's just habit. I get a little particular this way. It's not existing. It's brand new. So we're going to go in here and add a room. Call that room my garage. I'm going to do Control V because I copied that area. My garage is 811 square feet. I know that garage has a slab. It has 4 walls. I'm going to enter those walls. Now, if you use the wizard to do all this, great. It might save you a little bit of time. Because I already entered my existing house, a little too late to do the wizard. So, what are we, 811 square feet slab. My slab perimeter was 104 linear feet. You can see this is just data entry. I did my takeoff, so I'm just in data entry mode. How are we doing on questions? Anybody have any questions? Who's winning our most prolific chatter so far? So Lindsay is telling me that it's a tie between three-way tie right now. So let's hear some questions if you have any. My front garage wall area is 208. That's a new wall. I'm going to say this wall is not insulated. Okay, I'm not going to tie the hands of my client to insulate that. If you do show it an insulated wall, then you're going to gain a slight improvement on your proposed design. So if it's insulated, let's show it's a 2x6 wall. Then you probably should have them insulated. If they don't know, show it uninsulated. That's probably the best route there. So my front wall, I've got 2 windows in my front wall. Both are 12 square feet apiece. I'm going to leave my fenestration type there as residential prescriptive. I'm going to copy that window. You can just hit copy, go up here to a wall and hit paste. You got 2 identical windows. That's my trick of the day. Left wall, we know it was 314. Add 90 to that is oops, I hit the wrong button. 44 degrees for my left wall. The area of my left wall is 264 square feet. We're going to say that that is a garage wall with 0 insulation in there. Just verifying that. It has 2 doors. I'm going to add 2 doors. The first door is 120 feet. Now, here's where it's not a wood door. I've got a garage door imported from JE4. So this is going to be a U factor of 1.0. So it's just a metal door. So that's what I'm using here. Oops, I put that on the front wall. Drag it over there. Let me do this. I'm going to do my little trick here. Copy, paste that second door, I'm just going to change the area to 67.5 feet. Move on. Rear wall. How am I doing on time here? We're going to get this by 11 o'clock here. I'm going to turn up my pace a little bit. My rear garage wall is 208. It is a garage wall. Sorry, my dialog box pops up off screen, so that's why you're not seeing it pop up. Add a window. That window is 12 square feet. I could have copied one of those windows from the front, you know, but I didn't. And this is my right wall. Area is 152. We don't have any windows on that. We're going to change the wall to a garage wall. My orientation is 224. Cool. Last in this zone, we need to do a roof, 811 square feet. I'm going to say that that's a garage roof. There's no insulation. You can see that here. I already created this for the existing house. No insulation there. Good. Orientation, front of the house, 314. Slope is the same, 6 and 12. Good. Now I can go back and connect my interior surface from the laundry room. I can say that that interior surface is adjacent to the garage space. So what I want to do now is go back into my HVAC system. Now this might already be there, my distribution. I want to show that the existing ductwork not being altered with duct extension. Existing ductwork being altered with duct extensions. The duct extension is going to be less than 40 feet. So what I'm saying is these ducts are being extended with R6 duct. So that doesn't look right. How come I'm getting existing altered? There we go. That's what it should look like. My existing ducts, known the age of the house, I think this is a fairly new house. I think it was in 2000. I can assume those ducts are R6 based on our vintage table. So I'm going to leave it at R6. The extended duct's going to be R6. It meets my mandatory. I'm good there. Nothing on my residential tab. Nothing on my HERS tab. I could do refrigerant charge, but you know, why add that now at that point if they don't have to? So good. I'm good with this addition. We could run this right now and get an analysis for just that portion of the addition, but we know we got one more zone to add. So let's add that zone, and this is the garage conversion. So one thing I need to do though is add a new HVAC system. And that HVAC system is going to be that brand new gas stove. If you remember, my bonus room wasn't heated with the existing system. It's going to be heated with the gas stove, and they're not going to have any cooling on that. So let's go ahead and characterize that. Let's see, Hvac System Addition. We're going to define this as a new system. I've already got this here. It's a gas stove. The system type is a split DX. The heating type is a gas furnace. The furnace type is a room furnace. We gathered this information from the client ahead of time. It's 15,000 BTUs. It's a 70 AFUE furnace. So keep in mind that the minimum efficiency for a gas furnace, I think, is 64 AFUE. So this is better than a minimum efficiency gas room type furnace. I've characterized the cooling input as 0. That's going to tell the software that there is no cooling. So it's going to assume 14 SEER 11.7 EER for that. My distribution is ductless, no fan. I'm going to leave my cooling distribution as ducted attic are 8 because we know there is no cooling and the software is just going to remove all that stuff. So everything else is unchecked. So let's add our zone. We're going to call this bonus room. I want a bonus room in my house. That'd be great, right? It's all on the same floor. Let's check our dwelling units. There are no bedrooms in this, so that could be an issue if you have an addition over 1,000 square feet. You know, it's going to trigger indoor air quality based on the number of bedrooms. So just be careful of that. And let's see, our room is going to be bonus room. Area, what do we call that? I need to look again. 600 square feet, right? That is, let's see, we know we have a slab. We have 3 walls, right? We have a front wall, we have a rear wall, and we have a right wall, and we have a roof. Okay, I'm going to go back in to my existing house when I'm done with this, and I'm going to enter those interior surfaces between the house and the laundry room and the house and the bonus room, just so we don't forget. If I forget, you guys remind me, please, because our model won't work without it. Okay, slab on grade, 600 square feet. We have 54.5 linear feet of, oops, wrong one. 600 slab on grade, 54.5 linear feet of surface condition default, 20% exposed. Excuse me while I take a drink of coffee. This is Code and Coffee, by the way, so hopefully you guys are enjoying your coffee. We're gonna, oops, hit the wrong button there. We call this front wall. It is 200 square feet, R19 orientation, 314 degrees. Wall exception. Now we're converting an existing garage. The client says we're going to leave the siding on. We're just going to strip the existing drywall, insulate those walls, and go for there. So existing wall with siding, basically saying if I'm using existing siding, I can't do the continuous insulation. So this is fair game in this particular situation. I'm going to use the existing wall exception. That's going to make my analysis a lot more favorable. So it's going to compare me to the 2x6 wall without continuous insulation. So, okay, my rear wall is going to be 44 square feet. Again, R19 wall. My orientation is 134 degrees. Again, I'm going to use that existing wall with siding factor there. My right wall, I'm going to go back and do the windows if you think I forgot those. Sometimes I do them when I enter the wall area. Sometimes I don't. So 192 square feet, new R19 orientation is, what did I say that was? I forgot to write it down. 224. And that's a existing wall. Now, here's the dilemma. We're converting an existing garage that had garage doors, and we're infilling this. Some of that wall has infill, and they're putting siding on. So I'm going to choose not to do existing wall with siding on this. Now I could break out which amount of wall had existing siding on it and what wall was new and model those separately. I'm just going to assume the worst case and go, you know what, that whole wall we're going to consider it new. So even though we're going to put R19 insulation in that wall, we're just going to show it that we're not taking the exception for that. So let's add our windows to our walls. The front wall had, let's look at our model here. Those two 3050 windows. So we've got 15 square feet apiece. Those are residential prescriptive values. Copy, paste. We've got I had a typo there. R-A-E-R? R-E-A-R. That's how you spell rear. Add a window. That window was 10 square feet. We've got our right wall. We've got 3 fenestration openings. This one is a French star. I'm going to use my double non-metal clear default door value because I don't know if that's a NFRC rated door or not, so I'm using a default. Bippin says, if you have an existing wall with a small window, you're replacing that window with a bigger window. So you will model window as new window. Should we model wall as an existing or altered wall? If you're not altering the wall would be existing. If you're replacing an existing window, you could do it either way. You could say that your existing window is being replaced equal to the area of that existing window, and you can say the window being added new, the area relative to the amount of new area of that window. That's a lot of work, and it might confuse a plan checker. I typically just go, hey, it's a new window. I'm going to take a little bit of a hit on that, but it's really not that bad. The only hit you're going to take is if you verified existing conditions, because that existing window might be a single pane metal frame and you're putting in this really efficient window, you're going to lose the amount of credit from that existing window condition to the new. Otherwise, you're not missing much efficiency at all there. So you're going to be compared to, without verification of existing condition, you're compared to a window with a 0.4 U factor and a 0.25 and a 0.4 SHGC. So if you're doing the prescriptive window values, that the delta between those two isn't very much. So while I was talking, I entered my last 2 windows there. Let's enter my roof area, 600 square feet. Our 38 in that attic. We're getting close to our time. The pressure's on. I got to move out. Daryl's got a question here. Daryl, R19 in that wall with the garage door in it isn't part only 2x4. Apologists said they were reframing that wall, but I missed that part. Now it appears that that wall is 2x4, and let's do it. Let's do that right wall as a 2x4. Right. So we're gonna put let's say Daryl's R15. Sound good in that 2x4 wall? I just hate to put R13 in a 2x4 wall. So let's call it an R15 wall. That might be what I modeled anyways for for my solution. So good catch. Thank you for that, Daryl. I think that front wall may also be a 2x4 wall with R15. So let's go ahead and change that one to R15 as well. Sorry, this dialog box keeps popping up. Okay, we got our roof, we got our walls. What do we need to do now, right? We need to insert our interior services. Interior surface between the existing house and the laundry room. Interior surface between the existing house and the new bonus room. So I just like to type wall to, we'll just call it laundry room, LR. So we know that's 82 square feet from our takeoff. That is an existing wall. It's an existing R19 wall to be exact. Floor elevation. I know Martin says leave those at 0. The software fills it in. I just like to do it just to avoid any computer problems. That's just me. So if you like to leave that at 0, leave it at 0. Interior surfaces, wall to bonus room. And that wall was 382 square feet. And again, that's an existing wall. Existing, let's look at that. I think it's an R13 wall. It's an existing 2x4 wall. I know they're building this out as a 2x6, so we'll just keep it all 2x4 just for modeling purposes here. I'm going to say that that's an existing R13. I could go verify that vintage table. but I know I'm good on that. 0.7 adjacent to bonus room. Good. Are we done? Did we do it by 11 o'clock? Yahoo! All right. When the pressure's on, right, you got to perform. How many people have worked on projects and the client is chomping at the bit to get the results? So, I was nervous about this this particular project. So we've got a lot going on here. I mean, we took some, we added 1, 2, 3 new zones to an existing house. One thing I want to do is I want to alter these existing windows. Okay, here's a really quick tip. The client says, oh, let's change out those existing windows. They were modeled as double non-metal clear. I'm going to go up here and go edit, replace. Right, EnergyPro says, what type of feature do you want to replace? I'm going to replace my fenestration. Great, I'm going to replace the glazing. I'm going to say, I'm going to pick the existing condition, double non-metal clear. That was a default value. Double metal clear. Is that what my existing value was? I think so. We'll find out here in a second. And I'm going to do the prescriptive, residential prescriptive requirement. Let's see if I picked the right one. Global glazing not found. I picked the double non-metal clear. Gotcha. That's why it didn't work. I'll get to those questions in just a second. Fenestration, glazing type, double non-metal clear, double non-metal clear window. I'm going to put residential prescriptive value. Boom. Let's see if I got it right this time. Yay, 26 times. Good. So I've completed my model. It's 10:57. Yay. Let's take a look at our questions here while I bring up the results here. Luke says the value for elevation on the walls is meaningless. Yeah. And throw out by EnergyPro when it renders the model. Yeah, I agree, Luke. I just do that because I have a habit of being specific. So absolutely, thanks for that comment. So Daryl says, if you have time, clients get permits for replacing old 40-gallon water heaters. I would assume a electric water heater. No Title 24 done. Now doing addition. Can I take credit for a new water heater? Yeah, Daryl, you could, if that water heater was being replaced as an alteration, permitted at the same time as this other addition and alteration. Absolutely. Go into your DHW system and go in there and just say that's altered. Now, you have a choice to have it just put in what's being new, or you can have it HERS verified. And you would select that at the zone tab level on the residential, and we're going to say, okay, what feature am I going to verify? I'm going to verify domestic hot water. I could go in also and say I'm going to verify existing fenestration and get a bigger credit there. So good. Yeah, you could go from electric to gas. Performance wise, you could go from gas to electric, although you're going to take a huge hit for that. So if it's not the same time, no, technically you can't do that. So unfortunately, the standards are pretty clear on that. So you could probably do it, and not likely somebody would catch it, but that's really unethical here. So what we got here, ran the simulation with all this. Sorry, I can't run it during the live broadcast or everything crashes, but this is my simulation with all these features changed. The new utility room or laundry room addition, the garage addition, the bonus room with the new HVAC system. We get a really nice compliance percent savings of 7.4%. Let's just take a quick peek. Make sure we didn't make any blunders here. Climate zone 12, total condition floor area. We could verify that. Area of our addition. We've got 3 zones. We actually have 4, but one of those zones is an unconditioned zone, so it doesn't show up. No natural gas available. Let's look if we got all of our zone areas right. The existing house is 2127. Close enough. utility room addition. Well, yeah, a little bit different here. We actually have 166. I forgot on my solution to take out that little area for the water heater. And then our bonus room, again, is good. We could go in and verify all these areas, go into our fenestration, verify that we have all of our altered windows, all of our new windows, our opaque doors. This is the table for overhangs. It's quite exhaustive because I added a lot of those. Here's my opaque surface construct tables. I could verify that all my construction assemblies were modeled correctly. And then my slab, and then goes down to my mechanical system. Hot water is existing. My HVAC system, one of those is existing, one of those is new. Here's my efficiencies here. So good. Whew, that's a lot of work, man. Thank you guys for hanging in there. Thank you for some great questions. Looks like Elizabeth has a question regarding the wall exception. I guess I misunderstood and thought these are only available for ADUs. Yeah, Elizabeth, these are available now for E+A+A approaches. So you could take advantage of that. Now, the exception for existing walls with siding was something that we suggested for the 2019 code. It was so well accepted by the Energy Commission. They said, let's do this for the 2016 standards. I believe they're going to be putting out a blueprint on that. But I know Gina Rada covered it in one of our decoding talks when she was talking about ADUs. She did her decoding talk after I recorded my ADU series, so she had all these new tools and tricks available to her. So you can use that existing wall or extended wall for ADUs as long as it's converting an existing unconditioned to a newly conditioned. If it's a standalone, brand new built, then it's a brand new dwelling. You can't use that. So, but you can also use either extended walls now for performance on E+A+A as well as performance for, use the exception for existing walls with siding. So good. Yeah, Daryl, shameless promotion on your coffee cup. If you want one of these coffee cups, hopefully you were one of those people who typed a lot of questions. So I know I have a few Code and Coffee mugs that are going to be going out soon. So if you got one from the last broadcast, yay. I know I sent 3 mugs out to people. So anyways, that's it for today's episode. If you want to stick around for the after show, that's great. Give me some questions and we'll go through that. Otherwise, thank you very much. I would appreciate and love it if you hit that subscribe button. And likes are great.